All right, so we are going to start talking about piecewise functions. And so a piecewise function is when you put two or more functions together on the same graph. So what I mean by that is, like, say, I'm just going to go off on a tangent a little bit, but say you have a piecewise function that looks like f of x equals, and then it says, how do they have it written? Yeah, so they have, let's say, x plus 1 when x is, so I'm going to do a semicolon, when x is greater than or equal to 0. And then let's have another one that looks like x squared, and that's whenever x is less than 0. Oh, this one won't work, but that'll be okay. Yeah, it will. Okay, so I'm going to sketch a quick graph. So when x is greater than 0, so that would be all of the ones to the right side of the y-axis when x is greater than or equal to 0. So it is at a slope with a y-intercept of 1. Oops. Y-intercept of 1. And then the slope of the line is positive 1, so you're just going to go up 1 over 1. So it's going to look something like this. All right. So that's whenever x is greater than or equal to 0. When x is less than or equal to 0, it is going to be a parabola, the parent function parabola. So, but you're only going to draw half of it. So it looks something like that. And then, so if you notice on my, right here, when x equals 0, x is greater than or equal to 0, that'll be a closed dot on this that line function. And then since x is less than 0, you're going to put an open dot, kind of like you used to whenever you would graph inequalities, right there. So that means if you were to read this function, and I were to say, what is the value of f of 1? So f of 1, that would be, remember f of x, that's like when x equals 1. Well, that value would be right there, and that would be 2. Your y value would be 2. Okay, if I said, what is f of 2? You would go over to 2, and it would be right here, so it looks like the value would be 3. Okay, if I said, what is f of negative 1? Well, I didn't draw this that well. Say that's negative 1. So we would go, for the parent function, remember it's over 1, up 1. So this would be positive 1. If I said, what's the value at negative 2? That would be over 2 up to 4. So f of negative 2 would be 4. And on this one, if I said, what is the f of 0? So what is the value of f at 0? Well, since this one has a closed dot, the actual value will be 1. A lot of people get confused right there, but if it's a closed dot, remember it includes that point. If it's an open dot, it does not include that point. So long story short, this is just a way of putting different functions together. And there can be 2, there can be 3, there can be however complex they want to get. Usually you'll see 2 or 3 though, sometimes 4. Okay, so let's talk about evaluate the following, and remember that means solve, for f of x equals, there's your system. So we have f of 7. Which one do you think we're going to use? We're going to use the top one or the bottom one? Well, f of 7, that would be on the top one, because the top one is when x is greater than 4. Okay, so since I'm going to use the top one, I would just plug in 7 for my x. 3 times 7 minus 5 would be 21 minus 5, so 16. Okay, let's do another one. If I had f of 4, okay, which one would I plug it in there? Well, I'd plug it into the second one because that's less than or equal to, and this is 4, so that would be under that region. So that would be 4 squared, so the value of f of 4 would be 16. Okay, same thing, f of negative 3, which one are you going to use? Well, negative 3 is less than 4, so that would be under the second one. So So you would have negative 3 squared. So the value f of negative 3 would be positive 9. Okay, next one, I'm going to skip this one, but you would do it the exact same way, with the exception, okay, if you look, there's 3 of them. They have x is less than or equal to 1, when x is between 1 and 3, but not equal to, and then when x is greater than or equal to 3. So that's where you would plug it in. Okay, so I kind of talked about this a little bit, but so let's talk about when x, or graphing one of these again. This is the more basic one. So this is like f of x equals negative 2, or I'm going to write it even a different way than that. It'll let me. This eraser is not very good on this thing. So I'm going to write it as y is greater than negative 2, or is equal to negative 2, and y is equal to 3. So those are 2 horizontal lines. Y equals means horizontal. So when x is less than 0, less than, so you're going to use an open dot on this one. When y is less than 0, it'll be an open dot at negative 2. And do I go to the right? No, because that's greater than 0. We don't want to do that. So it would be a horizontal line going to the left. Kind of got off a little bit there, but that is a horizontal line. Okay, when x is greater than or equal to 0, that would be a closed dot. You have a horizontal line at 3. So it looks like this. So this is your piecewise function. Simple enough, right? Okay, I'm going to let you try this next one by yourself. Just pay attention to your slopes and your inequalities, and you will be fine. Let's do the number 10 together, because it has a parabola in there. I just want to do it together. Okay, when x is less than or equal to negative 2, so you go to, that's going to be a closed dot. It's going to be f of x, or if that helps you, write that in. Sometimes it helps people. So y is equal to 4. So you're going to go over to negative 2 up to 4. And this one will be a closed dot. Y equals 4 is a horizontal line, so that means we're going to go, since it's less than or equal to negative 2, we're going to go to the left. Okay, and then I'm going to skip down and do the last one. I'll save the parabola for last. So y equals 4. When x is greater than or equal to 2, that'll be another closed dot at positive 2, 4. And that's a horizontal line going to the right. Okay, so now this is in between negative 2 and positive 2. You have the parent function of x squared. So we know the parent function starts at the origin, goes up 1 over 1 in both directions, and then up 2 over 4. Usually we would write, since these are less thans and greater thans, we would write an open dot, but since they connect to those other closed dots, you are going to keep it a closed dot. So this is what that graph looks like. It's kind of cool. All right. I think you can do those other ones. Which of the piecewise functions are continuous? So they're wanting you to say the number. Which one is discontinuous? So what does continuous means? Let's just say you never pick your pencil up. And what I mean by that, you can draw a straight line. It could look like this, but you're never actually picking your pencil up. Discontinuous would be like it goes to here, then here. That would be a discontinuous graph. So they're wanting to know which numbers are discontinuous and which ones are continuous. Okay, this next part is very similar. We're going to do the exact same thing, except for now we have a few more parabolas. All right, let's do number 7. This will probably be the last problem I'll do on this video. I just think this might be the one that gives you guys grief. So we have, let's talk about the first one. That'll be the easier one because it's a straight line. Put y equals if it helps you. So when x is greater than 1, so it'll be an open dot at the beginning, your function, or this is a line, would be 3x plus 4. So I'm going to draw it, and then I'm going to trim it up with my eraser a little bit. So I'm going to go up to 4, 1, 2, 3, put a dot. And then my slope is positive 3. So up 3 over 1, up 3 over 1. Okay, so I want this to be whenever x is greater than or equal to 1. So I'm actually going to erase this dot. I'm going to make this one an open dot. And then, let me try that again. Draw my line. Ooh, that's ugly, but you get the idea. Okay, so this next one is a parabola written in standard form. Remember, you need to do negative b over 2a to find the axis of symmetry. So that'll be negative 4 over 2 times 1. So that ends up being negative 2. Then you're going to plug that back into the original equation. So I have negative 2 squared plus 4 times negative 2 plus 2. Stick that in your calculator and you get negative 2. So we know the vertex of the parabola is at negative 2, negative 2. Okay, so let's just go ahead and put that point in there. So that looks like it would be about right there. Okay, so is there an a value, or let's just go ahead and graph we have this right here. So it looks like, and I knew that was my y-intercept because remember your c term is your y-intercept. Okay, I'm going to go over the other direction and do that. So I need to go over one more, and if you notice, this is the parent function. Usually you would go over 1, up 1, over 2, up 4. So let's go ahead and finish it because we need to get to x is less than or equal to 1. So we need to get to our 1 value for x. So we're going to go over 3, up 9. Oh, what do you know? It crosses right there. That's kind of cool. So I'll go ahead and close that dot in since it was open, but it hits the same one, so it doesn't matter. And just for fun, I'll put this dot in here. So it looks like I have something like this, which does kind of look like a parabola. My line is pretty poor, but that is a straight line there, so it does go off a little bit. But that is your piecewise function. Well, before I cut you loose and start on your own, let's talk about a word problem. Okay, so we're going to write a piecewise function to represent the cost of candy. So a wholesaler charges a store $3 per pound for less than 20 pounds of candy and $2.50 per pound for 20 or more pounds. Okay, write a piecewise function. So it's going to look like f of x equals, then you draw a fancy looking bracket. So $3 per pound, what would that function look like? Well, that would be 3x. $3 times the number of pounds, and x is your pounds. And then you're going to do a semicolon, and this is for when x is less than 20. Okay, let's do the other part. So and it's $2.50 per pound, so 2.5x. You could put 2.50, it doesn't matter. So 2.5x, semicolon. My semicolons look like J's. But for when 20 or more pounds, so that would be x is greater than or equal to 20. All right, there's your piecewise function. Well, go ahead and try to do the rest of this. If you get stuck, ask questions. You can email me if you're not in class, or you could try to look at the answer key and figure it out as you go. Thanks for watching.